Hi everyone, what's up? Welcome back to my tutorial channel. Today we are going to work on 10 problems of topic 9a, the log-normal distribution and its application to option pricing. Alright, so let's look at the first problem. Question 1. Assume the Black-Scholes framework you are given S of t is the stock price at time t. The stock volatility is 25%. The continuously compounded expected rate of return is 8%. The stock pays dividends continuously at the rate 3% proportional to its price. The continuously compounded risk-free interest rate is 4%. The current stock price is S0 is 125. Determine the median of S3. The median of S3. So, there are two ways to work on this problem. The very easy way is just use the formula of the median. Here, let's summarize the question for a minute. We got 25% here, it's just the volatility, so it should be sigma. So sigma is 25%. The continuously compounded expected rate of return is 8%, and this is alpha. See that? The stock pays dividend continuously at the rate 3% proportional to its price, so this is just delta, right? Delta is 3%. Right, and the continuously compounded risk-free interest rate is 4%. This is just RF. This is the risk-free interest rate represented for the environment of the financial market. The current stock price is S0 125 and determine the median of S3. So remember that the median. First, the first solution. For the first solution, I'm going to just use the formula. Let me change color. I don't want to write in the red color. Alright, the first solution, the median of it is just like expected. Excuse me, it's not expected. The median of the median of S of t is S0 e to the alpha minus delta minus sigma squared over 2, the whole thing times t. This is the median of S of t. This is the median of S of t. See that? So the median of S of 3 is just S of 0. Here, anywhere you see t, you have to replace it with 3, right? So this is e to the alpha here is 8%, so it's 0.8 minus sigma is 3%, which is 0.3 minus sigma squared is 0.25 squared over 2. Let me erase this. Give me 1 second. I need more space. So I'm gonna rewrite this. It's e to the alpha minus delta minus sigma square half times with 3, right? Times with 3. This is the median of S of 3, right? Now what you have to replace the number. First, S of 0 is 125 times exp here, just like the e to the something, right? It's this the same thing, just different notation. Here we have alpha is 0.08, right? Minus delta is 0.3 minus sigma squared is 0.25 square half the whole thing times with 3, and it should be equal to, now I'm going to use my calculator to find the answer. So I got 125 times with e to the 0.08 minus 0.03 minus 0.25 square divided by 2, the whole thing times 3 in the exponent, and I got the answer here is 132.2328. That's the answer. Let me calculate one more time to make sure. First of all, 0.08 minus 0.03 minus 0.2. Write a formula of the median. But what if in the exam you forget the formula of the median? Show you the second solution. But let me write the answer here so that we're not going to forget it. So the answer here is 132.2328. Right, that's the answer. Now I'm going to show you the second solution. So I'm going to erase the board. This is my whiteboard, and I'm going to erase it. Okay, erase everything. And now I'm going to do the second solution. So I'm going to use a color to mark it. This is number 2 solution. Okay. The second solution is just look at the formula S of t. The stock price model under the assumption of lexical framework is S of t is equal to S of 0 e to the here we have alpha minus delta minus sigma square half times t plus sigma square root of t z, where z here is z follow the standard normal distribution, right? So in order to find now, so from here, what is S of 3? S of 3, this is the stock price model at time 3. It should be S of 0. S of 0. S of 0. Let me check and make sure it's alright. S of 0 here. So S of 3, S of 0 e to the alpha minus delta minus sigma square half times t. T here is 3, right? So I'm not going to use 3 in here. I'm going to use number 3. Right, number 3 plus sigma square root of 3 z. See that, z. So now in order to find the median of S of 3, we can first find the median of z and then replace it into this equation to find the median of S of 3. But what is the median of z? Z is a standard normal distribution, so when you look at the distribution, z should follow a bell shape. Right, bell shape is a symmetric unimodal. So remember that for standard normal distribution, the mean, the median, and the mode are 0, right? So here the median of z is 0. So the median of S of 3, you have to replace z here as 0. See that? And you're gonna have the median of S of 3 is the median of S of 3. The median of S of 3 is just S of 0 e to the alpha minus delta minus sigma square half times 3. See that? So this is the formula to find the median, and this is exactly the first solution. You see that? So the second solution is just how you record the formula to find the median, because sometimes in the exam you might be stressed out and you forget how to you forget the formula to find the median of S of 3. So this is how you record it. And then all you have to do is just replace S of 0 here is 125, alpha is 8%, delta is 3%, sigma is 25%, and that's all. You got the median of S of 3. So that's the first question. Now let's look at the second question. Question 2. The log-normal model for stock prices is given by S of t is equal to S of 0 e to the alpha minus delta minus sigma square over 2, the whole thing times t plus sigma z, where S of t is the stock price at time t, alpha is the stock expected rate of return, delta is the stock dividend rate, and sigma is the stock volatility. Which of the following is true? First, Z follows a normal distribution with mean 0 and variance 1. Z follows a normal distribution with mean 0 and variance with t. Z follows a normal distribution with mean 0 and variance t. Z follows a normal distribution with mean 0 and variance t squared. None of the above is true. Alright, so before I work on this problem, I have to trust one thing clearly, because many of you probably not gonna read the question carefully and pick the first answer right here, but this is not a correct answer. There is a problem between finance and statistics. In statistics, we notate Z as the standard normal distribution, and we never use Z for any other normal distribution except standard normal distribution. But for IFM, the author didn't really pay attention to that, and they use Z as just a regular normal distribution. So when you read IFM exam, you have to reprogram your brain to understand that Z is not a standard normal distribution. So you're not gonna pick the first answer, okay? So the first answer here is false, and the reason is in IFM, Z is not used for standard normal distribution. But it's for regular normal distribution. It should be, but they forgot it. They should use X instead. They should have used X instead of Z. Okay? Alright, so now let's go ahead and find out the answer. Before I find out the answer, I'm gonna rewrite the formula of the stock price model under Black-Scholes assumption. So let me use different color. I don't want to mess it up. Alright, let me write down the equation here. S of t is equal to S of 0, the current stock price, e to the alpha minus delta minus sigma square half times t plus sigma square root of tz. See that? So this is the right formula for the stock price, but now they use this model. So here you have to understand here that is Z here is actually square root of TZ. See that? And this Z, I'm gonna use Z star. I'm gonna use Z star here. This Z, it is Z star here follow normal distribution would mean 0 and standard deviation 1. There's a standard normal distribution. So from here we got Z should follow normal of 0t. You see that? 0t instead of 0, 1. So the Z in this formula is not the normal standard distribution, but it should be normal distribution would mean 0 and standard deviation square of t or variance t. See that? So the correct answer here should be the third answer right here. Z is a normal distribution would mean 0 and variance t. I think the author should, pay attention to the notation, because it's gonna, make a lot of people go crazy for this problem, because it's really tricky for them to understand that Z here is not standard normal distribution. But you have to accept this and try to reprogram your brain when you go into the exam, okay? Alright, next question. Question number 3. The log normal for stock prices. Can you see the question? Let me zoom it in a little bit so that you can read the question better. Alright, now it's bigger, right? The log normal for stock prices is given by S of t is equal to 10 e to the 0.03 t plus 0.1 square of tz, where Z follows standard normal distribution, calculate variance of S sub 1. Alright, so this question is a little bit tricky, isn't it? So for this problem, we have to recall a bunch of old knowledge from different courses like statistics, probability, and also finance. In order to find variance, remember that variance of a random variable x is equal to expected value of x squared minus expected value of x whole square. See that? So we are going to use this formula to find the variance of S sub 1. But in order to find e of x squared and e of x, we have to use the k moment formulas because we are working on log normal distribution. Alright, so here we work on S sub 1. So let me write down the equation of S sub 1. S sub 1 is equal to 10 e to the 0.03. T here is 1, so oh, my bad. It should be S sub 1, okay? S sub 1, not S sub t. Because we already got S sub t, so I just need S sub 1. S sub 1 is 10 e to the 0.03 plus 0.1. Square root of 1 is just 1, so we just need z right here. So right here is z. Alright, and it should be equal to 10 here is just e to the natural log of 10, right? Then e to the 0.03 plus 0.1 z, and then just simplify it to be e to the natural log of 10 plus 0.03 plus 0.1 z. See that? So in order, here's the thing. Before I do this problem, I'm gonna recall one more knowledge in statistics. So let's say I'm gonna recall some knowledge right here. Okay, I'm gonna recall some knowledge right here. Let's say y is equal to e to the mu plus, oh my, y is not working. Suddenly it's not working out in here. Why is that? I cannot write in here. Alright, let me rewrite. Let's say if y is equal to e to the mu plus sigma z, let's say plus, that is plus. Cannot do it. What's wrong with this? Alright, z follow standard normal distribution. So y here follow log normal with mean mu and standard deviation sigma. See that? See that? So if we have the log normal distribution like this, then the moment, the k moment of y is e to the y to the k is equal to, by the formula, is e to the mu times k plus sigma squared k squared over 2. So this is the formula to find the k moment. See that? So this is the second knowledge that we need to remember. So now we are going to use this k moment formula to find e of S1 and e of S1 squared, because we need that to find variance, right? So let me write that formula down here so we have more space for it. Oh. E to the mu k. My handwriting is so bad. My handwriting just so bad. E to the mu k plus I'm gonna erase this part because I don't need it anymore. I'm gonna erase this one. See that? Alright. So in order to find variance of s of 1, we first have to find its backwards value of s of 1, right? And here k is just 1, right? And mu in this case is this one, this is mu, and this is sigma. See that? This is sigma. E, yeah, this is sigma. Alright. So e to the s1, this is k is 1, right? K here k is 1, right? E of s1 is equal to e to the mu times k, and mu here should natural log of 10 plus 0.02, that is mu, times k is just times 1, right? Times 1, plus sigma is 0.1 square, times k is 1 square over 2, see it over 2, and that is e of s1, and the answer of it is, let me see, give me 1 second, okay? It should be 10.25. See it, 10.25. That is e of s1. Now we have to find e of s1 squared. So k in this k is 2, right? K is 2. So we got e to the natural log of 10 plus 0.02 times what k is 2, right? This is mu times k. I need more space, so I'm gonna erase this one. I need more space for it. Alright, and then plus sigma is 0.1 square times what 2 square over 2. And the answer here is, let's see, natural log of 10 plus 0.02, then times 2 plus 0.1 square times 4 over 2 is times 2. Then the e to the answer, it should be 106. It should be 106.1836. See that? So now we have e of s1 squared and e of s1. We can go ahead and calculate variance of s1. Right. Variance of s1 is e of s1 squared minus e of s1 whole square. So it should be 106.18 subtract 10.25 square. Alright. And the answer is 1.12. 1.12, that's the answer. See that I'm use different color to write out the answer. So answer is 1.12. See that this is the answer for this problem. And there's question number 3. See that? And the thing that you have to memorize in the exam is the k moment of a variable that follows log normal distribution would mean mu and standard deviation sigma. Okay. All right. Very good. Now let's move on. This is question 3, right? Now we are going to work on question 4. The log normal for stock prices is given by this formula, where z follows standard normal distribution. Calculate expected value of s of 5. So for this one, we are going to use the formula that is e of s of t is equal to s of 0 e to the alpha minus delta alpha minus delta time with t. So this is the formula to find. Let me see if it's the correct one. Let me try to remember. E of it should be, yeah, that's correct. And here we have to figure out alpha minus delta in order to find E of S of phi, right? So from here we'll have E of S of phi is equal to S of 0. S of 0 is 100, right? E to the alpha minus delta times phi, right? But we don't know alpha and delta, right? We don't know alpha and delta, but we know that alpha here from this equation, if we synchronize to the equation S of t is equal to S of 0 e to the alpha minus delta minus sigma's half square times t plus sigma's square of tz. So if you synchronize these two equations of S of t, we got 0.03 is equal to alpha minus delta minus sigma square half, and sigma here is 0.1, right? Sigma here is 0.1. If you synchronize 0.1 square of tz and sigma square of tz, so we got sigma, the volatility is 0.1. And from here we got this is alpha minus delta minus 0.1 square is 0.1 square over 2. And from here we can solve for alpha minus delta, right? It should be 0.03 plus 0.005, and it should be 0.035. So yeah, 0.035. And from here we use this to put into the equation right here. I'm gonna use different colors so you can see it. Alright, so from here we have to put it into the equation. From here go to here, okay? 100 times e to the 0.035 times 5, right? Times 5, and the answer is, let's see, e to the 0.035 times 5 times 100. It should be 119, right? It is 119. It is 119. See that? That's how you find the answer. 119. See that? Alright, so that is problem number 4. So the answer is 119. 119 is the expected value of S of 5. Alright, so let's move on to the next problem. The lognormal model for stock prices is given by S of t is equal to S of 0 e to the alpha minus delta minus sigma square half times t plus sigma square of tz, where z is where z is a standard normal distribution. Given that alpha, delta, and sigma are positive, which of the following is true for S of t and where t is positive? So let's check one by one. The first two statements, we need to compare the mean and the median, right? So I'm going to leave it there for the last. Let's look at the next two statements. The mean is this, and the median is this. Both of them are incorrect. The mean should be S of 0 e to the alpha minus delta times t. And the median is S of 0 e to the alpha minus delta minus sigma square half times t. You see it? So both of these are incorrect. So both of these are incorrect. Now let's check the mean and the median to see which one is better. So if you look at the formula, this is the mean, right? This is the mean, and this is the median. You see that? So now we are going to compare this, right? So we see that the mean is equal to hold up, I'm gonna do it this way. So first I'm gonna look at the median, right? Median is S of 0 e to the alpha minus delta times t minus sigma square, half square times t. You see that? And it should be equal to let me do different, one more step. It should be equal to S0 e to the alpha minus delta times t time with e to the minus sigma square half t. See that? And this is the mean time with e to the minus something, and here sigma is positive, so e to the negative exponent should be less than 1, right? I'm gonna call this a is e to the, we notice that a here is less than 1, right? So the median is less than the mean, right? Less than the mean. The median is less than the mean, or the mean is greater than the median. So the correct answer is the first one, and the second one is incorrect. See that? So for this one, the correct answer should be the mean is greater than the median. You see that? The mean is greater than the median. So that's question number 5. Now let's look at problem number 6. The log normal model for stock prices is given by this, where Z is the normal distribution. Determine the stock continuously compounded expected rate of appreciation. Before we do this problem, I have to point out that the continuously compounded expected rate of appreciation here is just alpha minus delta, so that you know what it is. Alright, so what we need to find is alpha minus delta. So let's look at the formula first. S of t. What is S of t? S of t is S of 0 e to the alpha minus delta minus sigma square half times t plus sigma square of tz. So if you look at the formulas of S of 4, it should be S of 0 e to the alpha minus sigma minus delta minus sigma square half times t here is 4 times 4 plus sigma 2 sigma z, right? 2 sigma z. So from here, if we synchronize S of 4, the two equation of S of 4, we got S of 0 is 100, of course, but we don't need that. We got 0.2 is equal to 2 sigma, right? Leading to sigma is 0.1, and we got alpha minus delta minus sigma square half is equal to 0.03, right? Because 0.03 times 4 is 0.12. See that? And here sigma is 0.1, so we have to have alpha minus delta is equal to 0.03 plus sigma square half, which is 0.03 plus 0.1 square half, and it should be 0.035. See that? So the continuously compounded expected rate of appreciation here should be 0.035. So that is the answer for this problem. That's question number 6. See that? So this is the answer. Now let's move on to the next problem. You are to estimate the non-dividend paying stock annual live volatility using its prices in the past 9 months. Calculate the historical volatility for this stock using the continuously compounded monthly return over the period. Alright, before we do this problem, there are 2 things we have to pay attention. First of all, the time step. The time step here is not a year but a month. That means H here, the time length, should be 1/12. You see that? 1/12. So in order to find sigma, we're gonna have sigma h over h. You see that? Square root of h. This is by central limit theorem, right? So first we use this data set to find delta h, sigma h. then use it to find sigma, right? And in order to find sigma h, we have to find the rate of return over each year. These are stock price, but it's not the rate of return. In order to find the rate of return, we have to use the formula RT is equal to natural log of S of t over S of t minus 1. You see that? So from here, we basically just have to, find out the rate of return first. For the first time step, we don't have the previous value, so we cannot find R1, but we can start by find R2. R2 is equal to natural log of 64 over 80. We take the new value over the old value, and it should be let me see what should it be. It should be negative 0.22. See that? And then continue. We got R3 is natural log of 80 over 64. So it should be 0.22. R4 is natural log of 64 over 80, which is negative 0.22. Then R5 is natural log of 80 over 64, which is 0.22. R6 is 0.22. See that? Just do step by step. Then we got R7 is minus 0.22. R8 is 0.22. And R9 is minus 0.22. And here for this problem, I want you to notice that there's only A values for the return rate. This is 1, 2, 3, 4, 5, 6, 7, 8. And among these 8, they have the same value to different side, right? We got 1, 2, 3. We got 4 negative number, and we got 4 positive number. So the mean of it, expected value of RT should be 0. You see that? And so we got what should be sigma square of it, sigma square of RT here. But here we basically have sigma square using time h, that is by month. So it should be, expected value of RT minus 0 whole. Hold up, it's not like that. So we're gonna have a summation of RT minus 0 whole square, the whole thing over 7, and it should be 8 times with 0.22 square over 7, because we have these A number are 0.22 to different sides. So when you square it, you don't need to worry about the sign. So it should be, let me see, it is 8 times 0.22 square, then divide by 7. It should be 0.055. See that? That is sigma square of so we got sigma h is square root of 0.055, right? That is the now I'm gonna work on the black color. Okay, so I'm gonna work right here. So we got sigma is equal to sigma h over square root of 1 over 12. So it should be square root of 0.055 over 1 over square root of 12, and it should be square root of 12 times what square root of 0.055. Right, excuse me, there's so many, there's no space here to work on this problem. So the answer here is you take square root of 12 times what square root of 0.055, and the answer is 0.81. See that? Which means 81%. See that? 81%. I repeat, delta H here is 0.055 in the square root, and square root of H is just square root of 1 over 12. See that? So that's how we find the answer. And the correct answer here is 0.81. Alright. Question 8. the log normal model for the stock prices is given by S of t is equal to 10 e to the 0.03 t plus 0.1 square of t z, where z is approximately where z follows standard normal distribution. Determine the 90 percentile of S of 2. Alright, so before we work on this one, I'm gonna write out, before we do anything, we have to write out the formula S of 2, right? Given S of t, we have S of 2 is 10 e to the 0.03 times 2 plus 0.1 square root of 2z, right? Square root of 2z. And so in order to find the 90 percentile of S of 2, we have to first find the 90 percentile of z first, right? So here the 90 percentile of z, right? We need to find, let's say if it is z, is little z, let's say that. So we got this probability that z less than or equal to little z is 0.9, right? Because basically the percentile here separate the lower 90% and the upper 10%. You see that? So the area to the right of the little z under the standard normal curve should be 90%, right? So little z here is basically just phi inverse of 0.9. You see it? And we are going to use the z table, right? The z table for it. So let me open the z table. The z table right here. So we know that the area to the left of the 90 percentile is 0.9, right? So we basically have to find the area that is very close to 0.9, right? So of course it should be on positive table, it cannot be on negative, right? So let's find 0.9. This is 0.9032. Let me see, this is 0.9015 and this is 0.89. Look at here. This is, let me mark it right here. Let me mark it right here. You see the red color, I mark it here. Let me zoom up the table. Yeah, you see right here. Alright, so I'm going to use the number between them because 0.9, actually it doesn't matter. I can either use the previous number or the next number, it doesn't matter. And this one is on the line of 1.2 and on the column of 0.08 and 0.09. So it should be about 1.28 to 1.29. See that? Whichever, or you can take 1.25, 85, doesn't matter. Here I'm going to use 1.29. So 1.29 is the 90 percentile of the student, 1.25 is the 90 percentile of the standard normal distribution. So I'm going to go back to this table. Okay, so this is 1.29. You see it? 1.29. So 1.29 is the 90 percentile of z, right? I'm going to erase this board because I don't need it anymore. I'm going to rise up here is 1.29, right? And I'm going to erase my work right here. So, the 90 percentile of S of 2 is 10 e to 0.06, 0.03 times 2 is 0.06, plus 0.2 square root of 2, and the 90 percentile of the standard normal distribution is 1.29, so we got 1.29. So plug it in, we got what? We got 10 times e to the 0.06 plus 0.02 times square root of 2 times 1.29, and we got 26.59. 99. Oh, I think I got it wrong. Excuse me. I used the let me see, 0.06 plus 0.2 times square root of 2 times 1.29, and take exponent and times 10. I got 15, excuse me, it should be 15.29. So this is the answer for this problem. That's the question number 8. Is that right? 0.0, oh, my bad again. This is 0.01, not 0.02. So it's wrong again. Let me redo it. Let me use a calculator again. 0.06 plus 0.1 times square root of 2 times 1.29, then take exponent of it and times 10. It should be 12.7, okay? 12.7 is the answer. So this is the answer. This is the 90th percentile of S of 2. Alright, so that is problem number 8. Now let's look at problem number 9. Consider the lognormal model for S of t. The current stock price is 100. The stock continuously compounded rate of return is 5%. And the means of S of 3 is 103. Calculate the stock continuously paid dividend rate. So for this problem, we have to find delta, right? Delta is the stock's continuously paid dividend rate. We consider the lognormal model for S of t. The current stock price is S0 is 100. See that? Let me erase it. My handwriting is so bad. The stock continuously compounded rate of return is 5%. So R is 5%. And the mean of S of 3 is 103. So we got expected value of S of 3 is 103, right? 103. But do you remember the formula of the expected value? It should be S of 0 e to the alpha minus delta times 3 times t, that is 3, is 103. S of 0 here is 100, right? E to the alpha here is 5%. Oh, my bad. Alpha is 5%, not R. Let me correct this one. Alpha is 5%, not R. R is the risk-free interest rate. So we got this is 0.05 minus delta times 3 is equal to 103, right? So delta is 0.05 minus 1/3 of natural log of 103 over 100, right? So let's find the answer. (0.04). 0.04 is the answer for this problem. There is problem number 9. Alright, let's look at the last problem. The lognormal for stock prices is given by S of 4 is equal to 100 e to the 0.12 plus 0.2 z, where z follows standard normal distribution and 0,1 determine the value of sigma square in the model. It's so straightforward. The formulas of S of 4. Let's write out the formulas of S of S of t first. S of t is equal to S of 0 e to the alpha minus delta minus sigma square half times t plus sigma square root of tz, right? So we got S of 4. If we follow this formula, is S of 0 e to the alpha minus delta minus sigma square half times 4 plus sigma square root of 4z. See that? And if we synchronize these two equations, S of 4 and S of 4, we got sigma square root of 4z is equal to 0.2z, right? Z cancel, so we got sigma square root of 4 is just 2 sigma is equal to 0.2. So sigma is 0.1 and the question asked for sigma square. So sigma square is, oh my gosh, why is not working? Sigma square is 0.1 square, which is 0.01. So this is the answer. So yeah, 0.01, 1%. Alright, so that's it for today. Thanks so much for watching. I hope you guys enjoy my video, and I will try to make more and more video this week. Hope you find my channel helpful for you to pass IFM exam. My channel is completely for free for people who really have high passion to pass IFM and also have high passion to, you know, follow the SOA pathway to become an actuary. Alright, so that is it for today. Thanks so much. See you next time. Bye bye.